Asymmetric encryption allows secure communication over an untrusted channel. But with symmetric encryption, we need some way to securely communicate the shared secret or key with the other party. If that's the case, it seems like asymmetric encryption is better, right? Well, sort of. While asymmetric encryption works really well in untrusted environments, it's also computationally more expensive and complex. On the other hand, symmetric encryption algorithms are faster and more efficient at encrypting large amounts of data. In fact, what many secure communication schemes do is take advantage of the relative benefits of both encryption types by using both for different purposes. An asymmetric encryption algorithm is chosen as a key exchange mechanism or cipher. What this means is that the symmetric encryption key or shared secret is transmitted securely to the other party using asymmetric encryption to keep the shared secret secure in transit. Once the shared secret is received, data can be sent quickly and efficiently and securely using a symmetric encryption cipher. Clever, huh? One last topic to mention is somewhat related to asymmetric encryption, and that's MACs, or Message Authentication Codes, not to be confused with Media Access Control or MAC addresses. A MAC is a bit of information that allows authentication of a received message, ensuring that the message came from the alleged sender and not a third party masquerading as them. It also ensures that the message wasn't modified in some way in order to provide data integrity. This sounds super similar to digital signatures using public key cryptography, doesn't it? While very similar, it differs slightly since the secret key that's used to generate the MAC is the same one that's used to verify it. In this sense, it's similar to symmetric encryption system, and the secret key must be agreed upon by all communicating parties beforehand or shared in some secure way. This describes one popular and secure type of MAC called HMAC, or a Keyed Hash Message Authentication Code. HMAC uses a cryptographic hash function along with a secret key to generate a MAC. Any cryptographic hash functions can be used, like SHA-1 or MD5, and the strength or security of the MAC is dependent upon the underlying security of the cryptographic hash function used. The MAC is sent alongside the message that's being checked. The MAC is verified by the receiver by performing the same operation on the received message, then comparing the computed MAC with the one received with the message. If the MACs are the same, then the message is authenticated. There are also MACs based on symmetric encryption ciphers, either block or stream, like DES or AES, which are called CMACs, or cipher-based message authentication codes. The process is similar to HMAC, but instead of using a hashing function to produce a digest, a symmetric cipher with a shared key is used to encrypt the message, and the resulting output is used as the MAC. A specific and popular example of a CMAC, though slightly different, is CBCMAC, or Cipher Block Chaining Message Authentication Codes. CBCMAC is a mechanism for building MACs using block ciphers. This works by taking a message and encrypting it using a block cipher operating in CBC mode. CBC mode is an operating mode for block ciphers that incorporates the previously encrypted block ciphertext into the next block's plaintext. So, it builds a chain of encrypted blocks that require the full, unmodified chain to decrypt. This chain of interdependently encrypted blocks means that any modification to the plaintext will result in a different final output at the end of the chain, ensuring message integrity.